Welcome everybody to this new edition of the CVA Social Club from the Enterprise Blockchain Working Group. So my name is Dennis Flood. I'm chairman of the Enterprise Blockchain Working Group of the Crypto Valley Association. And in that context, we always do couple of times during the year some sessions with people that are working in the environment of enterprise blockchain solutions. And today I'm very pleased to welcome Bjorn Tackmann from DFINITY, the internet computer. Quite interesting to hear about that, what is the latest stages there and how we can actually use that for enterprise blockchain solutions or enterprise solutions in general. Because it's not all on blockchain, but it's a decentralized technology, which is good. Bjorn is now 6 years with DFINITY.
Correct.
And
yes.
Before that, you worked at the IBM as well in the research area. That followed then after your PhD at the ETH here in Zurich. And in that context, I think you have a PhD in cryptology and computer science, and then everything comes together. And it was kind of logic that you come here and work at DFINITY. And thank you very much for taking the time and welcoming us as well here in the DFINITY Foundation's headquarters in Zurich. And the internet computer I read has over 1,000 person years of development inside.
Yes.
And so are you happy with the result, or is the computer already finished? Or will it ever be finished?
So it's not finished, but it's fully operational. And what I mean by this is that we have a pretty ambitious goal with the internet computer. And let me maybe explain this, and in particular how it differentiates itself from other decentralized technologies and other blockchain-based projects. So if you think about like software and data, then like you basically have two ways. If you want to deploy some software, if you want to store some data, you have two fundamental ways of how you can do about this. First, so option A, you can use your own hardware and you can run your software and store your data on your own hardware. And option B is you use someone else's hardware, right? That's basically the two options. If you go with option A, then, I mean, you retain full control, you retain full ownership, but you bear the entire load of maintaining this. So you have to make sure your hardware is operational, fix anything that is broken. You have to keep your operating systems up and secure and always up to the latest level of security patches. You have to debug any upcoming networking issues. So it's a lot of work that you incur if you want to keep a service running up 24/7 by yourself, even if you're a company that's a significant load that you're taking on. With option B, it's kind of the opposite. It's like someone else takes care of operating the service, right? That's what you pay them for. Usually today you would maybe deploy to a cloud provider and they make sure the infrastructure is up, well, mostly up. They make sure that whenever something breaks, it's going to get fixed. But on the flip side, you give up all of the control, right? Now they are in charge of your code and in charge of your data. Most likely, if you're deploying to a cloud, the data will be immediately transferred to some Palantir database, I suppose. Someone else can just flick a switch and you lose access to your code and data. And so that's a pretty bad trade-off, right? So either you have to go with option A or option B, and neither of them is really good. And so
and you have an option C, huh?
Yeah, exactly. So at DFINITY, what we want to do is we want to think about this in an entirely different way. Like if you think about the internet today, like the internet is fantastic, right? Any two entities, basically all over the world, can immediately communicate, no matter where they are. It's fast, it's cheap, it's fantastic. You are just connecting to the internet, then you're using shared infrastructure. If you want to make this secure, you can add some cryptography and it's going to be secure. So you're fine on that front as well. So that's great, but the internet is very ephemeral, right? If you send a message, it goes through the internet, it drops out somewhere, the internet doesn't remember. And so we want to think about code and data as basically, or about the internet computer as extending the internet for code and data. So like you can think about it as, okay, you now want to have a program that you want to run, maybe personal, maybe as an organization. You want to keep control, you want to keep ownership, but you don't want to run the infrastructure. So what ICP is supposed, the Internet Computer Protocol is supposed to achieve is to give you this, like you can just deploy to the network. You will have to pay for the resources you're using, just as you do with your internet provider uplink, right? You pay for the resources, but you don't have to take care of having the infrastructure itself operational. And so that's the grand vision we have. It works, but of course we're not at planet scale yet, right? So the Internet Computer Protocol is live since May 2021. So by now it's 4.5 years, pretty much. And you can use it, it's usable, it scales pretty much, but not yet planet scale, right? And so in that sense, we are extremely proud of what we have achieved. I think it's really, I'm so proud of all of our teams in what they have achieved through their work over the last overall like 10-ish years. But this is not the end, right? We're going to increase the capacity, we're going to extend functionality also in the future. So it's not finished in that sense.
Mm-hmm. And now, as you said, it's 4.5 years that you're live. Now, quite interesting. So now really enterprise solutions, or solutions that you develop for corporates, together with corporates, for enabling them to have applications on the internet compute and so on. What do you have? What kind of examples do you have? What kind of showcases do you have?
Mm-hmm. I would maybe split in two cases here, because as with a network, there is the internet, which is a public network that is shared among everyone, and that's useful for applications that everyone is supposed to access. And then there's also you can also have an intranet, right? For applications that you just want to use within a certain context that don't need public access, you usually would deploy them on an intranet. And so the same thing kind of exists with ICP. So ICP, the mainnet, is kind of the public internet. We also have an intranet version of this, which we call Utopia. And that is particularly well suited for certain types of applications that we see more and more for, I guess, also political reasons recently. And so I want to maybe focus on one case in the Utopia one first, which is a project that we do with the UN Development Program, the Monetary Authority of Singapore, and the Central Bank of Cambodia. And it is a use case in Cambodia that's going to be based, starting, I think, Q1 next year, going to be based on a Utopia, so on an intranet version of the Internet Computer Protocol. And so the idea here is that in Cambodia, there's a lot, like compared to Switzerland, there's a lot more like informal business. There's micro-SMEs, small businesses that serve a larger part of the economy. And they are by how they work, they're a lot more informal. Now, sometimes they still need access to financing. They still need access to loans for whatever they need to buy to keep their business operational. But now they face a problem, which is, since they are so informal, there's very little documentation. And so they cannot just go to a bank and get a loan, because they may not have collateral they could give to the bank. They have kind of partial documentation. And so this project is more than just a technical thing. It's like an entire like use case solution. Mm-hmm. And the idea of this entire project is to bring more like credentials, more data in a trustworthy way in a platform where banks can access that data and use it to make their risk estimate about a certain loan. So
with the data, you mean like balance sheets, or even like a debtor book that you see, okay, how many incoming funds does the customer have, and
could be, but it could also be, for example, utility bills, and so that you see, okay, this SME, micro SME has paid their utility bills always on time over the last 3 years. Probably they were pretty trustworthy. And then maybe you have some other, maybe they did a bigger contract some year ago, and they can have that as kind of a credential. So will be very, probably every case will be slightly differently what kind of documentation they will have and use. But the idea is to make this kind of a trustworthy, verifiable data sharing between the providers of that information, which could be banks, other authorities, could be utility companies, whatever. And on the other hand, the consumers, which are then banks that make the decision about the loans.
So it's actually that the other parties are then verifying what this particular small enterprise or the micro enterprise actually has, and then that gets automatically collected in that kind of marketplace. Or how can I envision it? Is it then like a platform where I go as a small or medium enterprise and apply for a loan, or?
It's more like the bank goes there and says, okay, here is a set of requirements that we have and that we want to have fulfilled. And then the platform can see whether there's someone who can provide these, and they can provide this to the platform, and it's going to be forwarded to the bank. So that's basically the idea. It's like the SME will not interact with that platform. It's kind of between the entities that provide the data or consume the data.
Okay. So the SME still needs to go to the bank actually.
Yes.
At the end.
Yes.
Okay.
It's not a cryptocurrency solution. It's really about document integrity.
Yeah, that sounds quite interesting. So looking forward to hear how successful that has been launched, and then how good the small enterprises or small medium enterprises there will.
We of course hope they will flourish.
Get to more loans. Yeah, and that is on the private environment.
That's on the Utopia part.
The Utopia platform. And then on the public one, what kind of enterprise use case you have there developed in the last 4 years?
Yeah, one that I would highlight is a collaboration with Federitaly, which is a government agency in Italy that takes care of the Made in Italy brand, and the Origin Foundation, which is another entity here in Zurich that has done actually the development on this. And so the idea was of this project is, it's live, is to bring kind of the Made in Italy part on chain. So if there is a company participating in this program, they can basically print a QR code on their products, and if you scan the QR code, you get to the corresponding application on the computer where you can read kind of what makes that product made in Italy, what's the value provided, and so forth. So this is something which as an application is inherently public, right? You want every potential consumer of these products to be able to validate this information about the product. So this is something that clearly has a focus on ICP mainnet. So that's also where it's built.
So basically a very similar case, just that there is not the bank that asks for trustworthy information and data. That is when the consumer asks for trustworthy and validated information. Because I think that Federitaly is an audit company, isn't it? They are doing a lot of audits for these products, when I understood it correctly.
That's a good question. I don't know what exact part of that kind of value chain in the verification process they play. So for us, they're kind of the entity we talk to in order to understand the use case, but like we're more on the technology side. So I'm not sure how exactly that value chain.
Basically, on the sources that I have read by preparing this meeting is that they are really taking the production companies or the producers, the farmers, the winemakers, and so on, really through an intensive auditing process.
Of course, but this they do for the main.
So they are actually validating then the data that is then in the system in there. But interesting, because you have not mentioned any kind of trade cases at the moment as showcases. You have really so where really value gets moved from one corner to the other. You really broad cases where it is about accessing rights, accessing information, accessing validated information. That's quite interesting that people are then taking here the internet computer, I guess because it is decentralized and it is non-manipulatable and it is.
There's actually one part. Let me try to keep this as non-technical as I can. But there's one part that is, from a technical perspective, that is very specific about ICP as a decentralized protocol compared to basically everything else. And that is, what information do you need as a client to validate the correctness of information that you read? Like if you think about a blockchain, like if you think about Bitcoin or Ethereum or whatever, you basically need a copy of the blockchain in order to really, like on your device, decide whether a certain part of information is correct or not. There's some simplified cases like Bitcoin SPV where you only need block headers and not the full blocks. But that aside, you need a significant state, like at least tens of megabytes, usually more. And so for ICP, that information is a very compact public key. So we use a lot of threshold cryptography in ICP. That's kind of our specialty. That's how we roll. And so in order to verify information from ICP, you just need a like 100 byte of static information. And then any response that comes from ICP, you can immediately validate for authenticity just based on this. And so in particular, you can validate authenticity in every web application, like on every embedded device, basically. You can do this, which would be completely impossible with other types of blockchain or blockchain-like technologies.
Yeah, that's probably as well. I mean, on your website, DFINITY website, you claim as well that actually, smart contracts is the big buzzword.
Yeah.
And a couple of years, everybody was talking about smart contracts and how important they are, and they will change the world and so on. But at the end, I think the reality, as usual with hyped technology, was a little bit. Yeah, I mean, there are use cases and so on, but you say as well that smart contracts are just not, they just don't have enough data. And that's why they can only fulfill their job limited. Why I think you're claiming that with the internet computer, this data restriction is actually solved.
I mean, it's a lot looser in a sense. There's a lot more data you can store. So if you look at an application that is built on Ethereum or built on Solana, then what you will usually see is that there is some token component of that application that actually lives on the blockchain as you would expect it. And so if you do a transaction on tokens, that will incur a transaction on the blockchain. And that's perfectly suited for certain like DeFi cases, right? If you look at DeFi and you just want to exchange token A for token B or take a loan in token C for token D or whatever, then this part of the application actually lives on chain. But all the rest in those systems is actually off chain. So if any more heavy computation has to be done, that is still hosted on a usually centralized server in the cloud today. Or if you use a front end in order to interact with a smart contract, that front end will be stored in the cloud. And now this may seem like a theoretical concern, and why would you care? I think one great reason why you care is security. So you may remember that half a year ago or a year ago, there was one of the biggest hacks ever. That was the Bybit hack. And the way this was executed is that someone got access to a machine of one of the lead developers that could deploy the front end. And so what they then did is they introduced malicious code into the front end while it was on the developer machine. And the developer was pushing a malicious version of the code out to AWS. And now the code was pretty specific to exactly attacking certain wallets at Bybit. So it was pretty smart. It was a well-run attack. I mean, we have to give them that. And it was successful, right? And the problem here was that there is the full control over the front end was with one developer, and later it was stored just on a single cloud server. And so in the internet computer ecosystem, we think that's not a good way of storing such applications. We think if these aspects of the applications are crucial for the security and the correctness of the application, then they need to be handled with the same care that we use for the token part, because the token part was fine, right? It was really just a front-end exploit. And so in the intercomputer protocol, you can host the entire application fully on-chain. You can host the backend on-chain, like we call them canisters. So basically one smart contract on their computer can have up to 500 gigabytes of memory, which is approximately as large as complete other blockchains, right? You can host the front end on-chain. So by hosting it on-chain, you make it verifiable that there is no backdoors. So the entire thing becomes a verifiable application that before using it, you could validate everything that runs on-chain. And so you can really be sure that nothing has been tampered with when you use these applications. And so we think that that is kind of a missing piece in the current Web3 story that we have to solve, and you can solve it on ICP.
And I mean, that's probably then the link as well to the enterprise world, because
Exactly.
what's an enterprise? What are enterprise solutions? Actually, they are always working on business critical processes within enterprises. And the last thing you want to happen is that they are corrupted.
Yeah, exactly.
That's what we're saying. That's why I think this solution is quite good. I want quickly to open as well to the audience for some questions if they have. Please.
I can justify the first one. So I'm not a technical person. And I still don't really understand. So can I imagine it the way, so let's say comparing it to other, let's say the Ethereum blockchain, so is my understanding correct that while on the Ethereum network, there's like there's a smart contracts which are running on chain, and then typically DFs are then deployed off chain as you explained, whereas on the internet computer, the full stack application is running on chain distributed, which means that they are then each and every node operator is running the full code and verifies every time the application is executing something. Is this?
Yes, that is correct. The internet computer uses a different model of decentralization. I can go into that later if you want to. But using this, we call it deterministic decentralization. Using this, we can use a lot lower replication factors. So usual applications run with like 13 times replication, but we have many of the subnets. So the network scales horizontally. When we add more compute, more machines to the network capacity grows. So that's very different from other blockchain-based networks. And so due to this construction, we can actually offer a lot more resources to the individual programs. So the processing capability of the network is just so much bigger that we can enable hosting full applications on chain, which is difficult otherwise.
And is it true that so in the public domain that you're running, so I could set up a node and then I could basically deploy my own code, which would then be running on the entire network? Is this is it a similar logic, or you have some sort of a validation mechanism that?
It's kind of decoupled. You can use you don't need to run your own node. You can just deploy to the network. You can validate everything you get from the network cryptographically. There is no need for you to run a node. However, you can run a node because you want to contribute capacity to the network. Now, the process of running a node is a bit different from other blockchains. For example, we use very symmetric configurations of the nodes to ensure that they have approximately the same speed in processing and so forth. So there's a couple of differences, but you can become a node provider on ICP and contribute to the network. But you can completely decouple this from using the network.
Probably that's a good bridge to my next question is, so what does it actually need? What do I actually as a corporate, as an enterprise, maybe a small or medium enterprise or a larger enterprise, what does it actually take me to release and program, let's say, a website or something on the internet computer? What do I need to take?
Yeah. So we are like since we see ourselves as kind of a decentralized cloud, we try to be in line with web standards, right? So what the programs that run on the Internet Computer Protocol use a standard called WebAssembly, which you probably have used multiple times today without noticing, because every current browser supports it, and there's lots of plugins that are used in the typical internet. So it's a by now it's a almost invisible but important part of the web infrastructure. And so back in 2019, when we designed those parts of the structure, WebAssembly was still pretty nascent. We were among the first ones that were using WebAssembly in the backend. But today there's actually like Fastly, Cloudflare, a lot more companies that offer also WebAssembly hosting. In that case, in a centralized backend, we offer it in a decentralized backend. So it's a pretty widely used standard today, and there's lots of compilers that compile toward WebAssembly. However, it's still a bit of a nascent standard in terms of programming backend. So there's some part of the API that we had to fill in because the standard didn't have them, and that are ICP specific. So if you can compile to WebAssembly, you need a specific software development kit though to make use of all the functionalities that ICP provides. We at DFINITY provide two software development kits. One is Rust, which is a widely used system-centric, memory-save, pretty modern language. The other one is Motoko, which is one that we built in-house, which is more high-level. If you're learning new, it should be easier to learn than Rust. It's very well integrated, of course, with all the Internet Computer features. So it's a different approach. Those are the ones we use or we provide as DFINITY. There's a couple community-driven ones for JavaScript, for Python, for C++. So you need this kind of software development and the skills to do that. Okay. And then you can just deploy, basically. And if you want to just try it out, we have a couple things as well. So one is this year, it's Caffeine. It's kind of our newest venture. It's an AI-based tool that you can use to build applications, in particular, whatever prototypes, smaller applications is fantastic to do this. Caffeine.ai, if you want to try, you'll get free credits to start. And so with this, you can just chat with an AI on the other side. You can tell it, oh, I want to have a website for my party where people can register and later after the party can put all their photos so they get shared and people can like photos. And then it's going to build an application that does exactly this and deploy it directly to the Internet Computer. Or as an enterprise, you could use that, for example, for prototyping something that you want to build and see how your partners or customers or whatever like the ideas. And depending on the complexity, it may be enough, or you may still have to do some other development later.
But I think, when I look at the corporate world, and I mean, we do as well in my company a lot of product developments with corporates and so on. Then, of course, I always see that they are working, of course, as well with a legacy. Yeah. And they are working with a standard procedure and people that are, working with standard codes and so on and so on. So is it as simple as you say to develop, or do I need then somebody from DFINITY that helps me on the project as a corporate when I'm really interested in doing a solution like the UN thing that you did, for example?
So I think first of all, it depends a lot on whether you want to target mainnet, which has a pretty easy entry, or a utopia where you have to where you have to set up the network, which is kind of a complicated process by itself, by nature, because you're setting up a decentralized network. So that by nature is harder than just kind of installing a single computer, right? But if you're just thinking about the software development, I mean, sure, there would be some level of learning curve for everyone who adapts, but like if you have general purpose programmers in your company, they will be able to adapt. Or we also have a program called the ICP Alliance, in which we have a couple companies that focus on developing on ICP. So if you want to outsource the development then to a different company, that's also an option. So I think it depends on the particular case. But it's like, this is not rocket science, right? It's like building software, which is what software developers do.
Yeah, but in a corporate environment, it's always a bit difficult, especially when you go to the large corporates. I mean, when you have a small and medium enterprise, they probably can, oh, I have a business idea, I do that, these things. But in the corporate sizing, in the Crypto Valley Enterprise Blockchain Working Group, we once had really deep sessions on, okay, what are the success factors for enterprise blockchain solutions? And we actually concluded them on 5 ones. So first of all, it needs to add value in the means of it needs to replace something or make something better that hasn't existed before. Because why corporates are like that? Why changing a winning horse?
Yeah,
you don't do that. I mean, we had enough use cases about, oh, we need to replace payments. Yeah, but you don't need to replace domestic payment because they work already very efficient. When you want to use something, then do cross-border payments. And these things. It needs to be a value add. And then another thing is that it needs to be easy to bring real world assets into digital assets so that they are exchangeable or replicatable or presentable. Like in this Italy project, I mean, a bottle of wine, how you bring the quality of a bottle of wine into a on-chain solution. That's the thing. Then, of course, the reach of the people, how many participants you have, how big is the network. And the fourth one, apart from a governance model, which is the 5th one, but the fourth one was the integration with existing workflows, what we concluded there. So because usually you don't go into into a blue ocean or greenfield environment, there is usually already something. There are already databases that you need to connect. These databases are centralized. There are workflows you need to correct. There are enterprise resource systems you need to connect and so on. How I think this is quite complicated with having a decentralized solution connecting with components of an enterprise which are more in the centralized environment.
Not necessarily. It depends a lot on the particular case. So as I mentioned before, like ICP tries to speak web as much as we can. And so in particular also the smart contracts, the canvases on ICP, they speak web as much as we can make them speak web. And so in particular, that means they can offer an API to the outside that is HTTPS, right? So you can just make an HTTPS call to a canister, and the canister will be able to respond to it with an HTTPS response. So there's no particular module you need to put in between. It's just from an if your existing system can make an HTTPS out call to do an API, which is today the most common way of doing APIs, then the canister will be able to answer to that API call. On the flip side, the canister can also make HTTP calls, which is also something that other blockchains usually cannot do. And so the canister can both provide an API to the outside and consume an API that is provided by an existing system. And so depending on what parts of an entire system you want to potentially want to move on-chain on ICP, you can keep other parts off-chain, and that's still going to work and communicate as long as everyone speaks HTTP, which again today is kind of the standard way of building APIs. And so in that sense, it's hard to generally answer all potential use cases, but it gives a very good tool set to integrate with existing use cases, also in a way where you maybe move things partially.
Okay, so what would be then the kind of use cases or sub-use cases or partial use cases you would say if a corporate has these and these issues or topics or faces these challenges, really thinking about the internet computer would be a good option. What would be your advice to the corporates?
So there's again the two different things. One, if I answer the utopia, the infranet one first. I mean, we've been talking to lots of different entities over the last months, which relates to the kind of degradation of political culture and trust internationally. And so these are usually like government-like or NGO type organizations that now realize, oh, they are actually putting a lot of trust in the United States-owned clouds, right? And they realize that they don't feel comfortable with this, whether it's an existing or a new use case. And so they now realize that they actually care about their own sovereignty, about their own data. So a lot of the contacts we have these days and upcoming projects in the utopia space are really about specific parts of their data, which are super sensitive. So it could be related to weapons, it could be related to money, like these types of things where you really, really want to make sure.
Kind of paradoxal. I mean, it's a super sensitive data, and you are, instead of putting it into a safe, centralized and protecting it, you're putting it.
What you're using then is the utopia vision, which is the one where you operate the infrastructure. So you only gain if there's some independence between the different parts that operate that infrastructure. So you will need, for example, multiple different data centers, or the nodes should be controlled by different entities, for example, in the same country or in the same government. So you actually benefit from the guarantees. Otherwise, if one controls all nodes, you don't gain. Right? So but what Utopia helps you in that case is to protect the integrity against insider attacks. So now, once you have this, even if there's one party that for whatever reason is malicious and tries to kind of change the data or read some data they aren't supposed to, they cannot, because the network is not going to allow them. So if you are willing to take this additional, it's additional complexity, right? It's additional complexity, but if you're willing to take this, you get a significantly increased level of security and sovereignty. And so it's use cases that really benefit from this, where we see now a lot of requests for Utopia. And for mainnet, I think it's really, if you want to build something where you may want to integrate with newer things like stablecoin payments, all that kind of thing, but your entire information flow, you want it not to be hosted, like you don't want the trust of the cloud. You want to have this thing secure. I think that's a case where I would say, okay, then if you want this, or if you want public verifiability of what you do, then it's a case for ICP mainnet. So as with Federally, like you can go and validate not only the certificate that Federally gives you, you could validate the actual software that generates that certificate. Right? So it's like you get a very sophisticated level of verifiability that you cannot get otherwise.
Okay. Very promising future for a lot of confidential or sensitive data that we have out there. There's some more questions from the audience.
How would you see, or how would internet computers watching solutions will be on blockchains and their platforms? And maybe they will create their own blockchain ecosystem. And how you see your position, because BlackRock, Widow, or all the others are trying to sell stuff now. How do you see the future in large institutions, blockchain?
So besides ICP solving a different problem than other blockchains, so it's not really necessarily competition for us. One strength of ICP that I have not mentioned at all so far is that ICP is very good at integrating with other chains. So an ICP smart contract can make outcalls, or it can hold Bitcoin, it can use Bitcoin, it can make outcalls to Ethereum in a way that is secured by the network itself. So ICP can enable smart contracts to interact with tokens, with contracts on other chains, right? So for us, if there's more other chains that we need to interact with in order to help the project, the projects building on ICP, that's fine. We can do this. So for us, we're like, that's not competition for us. That's collaboration. And so that's the way we see it. I don't think we really have competition in that space.
Mm-hmm. Andras?
I don't know if you're finished.
Yeah.
Yeah. Okay. Can you share a little bit about, I don't know, is there a consensus mechanism on the network, and what are incentives to basically, I think you said, to contribute resources?
Yep.
By running a node?
Yes. So ICP is what other blockchains would call a sharded network. We call it a subnet, a network consisting of subnets. So there is groups of nodes, again, these subnets, that together run a consensus algorithm. So the consensus mechanism we use is a standard threshold consensus. It's kind of I would say, if you think about the traditional consensus, it's like PBFT, but moved to a blockchain context. So it's a bit simpler because we use the chain structures. But it's like, it's a pretty cool thing, but it's not the most groundbreaking feature that we have. I think it's a very good consensus mechanism. It's very fast, but it's not our main distinguishing factor. What is our main distinguishing factor is that we build this threshold cryptography around it. So every subnet has cryptographic keys that are whole distributed among the nodes. So not every node has a copy, but only all nodes together have a copy of the key. And this we use in order to do this verifiability of information. We also use it to do the interaction between the subnets. So every subnet does its own consensus, every subnet does its own cryptographic key operations, and then they communicate with each other using what they do with this cryptography and consensus. That makes sense.
Is necessary to actually achieve consensus?
We also, no, we use it in one particular part of the consensus, but it's more like that's what we do. We build it on top of the consensus as part of the core protocol, but we need it on the next layer to do the interactions. So that's kind of I just meant like this is the part that is really unique to ICP that doesn't exist elsewhere, whereas the consensus is good, but you could use a different consensus algorithm.
And the incentives?
The incentives is if you're a node provider, you have to ICP has a governance system where everyone can participate. So you can get ICP tokens, you can stake them in the governance system, and then you can participate. And so the governance system will decide about applications to become a node provider, basically. So if you want to become a node provider, you say, hey, governance system, I want to run a node in the following data center. And then the governance system will say, look, this node is not something that we need because there's too much capacity there already. Or it will say, oh, that's fantastic. We always wanted to have a node in Cambodia. We don't have one. So great that you're offering one. And we gladly accept you to the governance system. And then if you run your node and if your node contributes to the network, you will receive token payments from the network that will remunerate basically your expenses for running the node, plus of course an upside because you have work keeping your node up and running, and the network wants to help you in providing good service.
Good. Please.
You just mentioned that smart contract can call HTTP or do HTTP requests.
Yes.
Does that make it a bit easier to hack this smart contract?
Does it make it easier?
Because I got done completely, how should I say it, completely designed data that may destroy your smart contract.
I mean, you can always have bugs in software, right? And you can write code that has bugs. But I don't think it fundamentally changes the picture here, because your smart contract will anyway process data that comes from the outside world. And the main difference here is usually smart contracts process data that is actively sent by users. In the HTTP case, the smart contract is processing data that it requested from the outside world. But it's still kind of the same fundamental thing. So I don't think it makes hacking easier or harder. Of course, if you have a more complex software system, you may, just due to the complexity, you may introduce additional things. But I don't think this particular feature, as a feature, is something that adds vulnerabilities.
Mm-hmm. So it really comes down to find the right use case for using this decentralized internet computer.
Mm-hmm.
And that is probably what a lot of corporates will get engaged with. And I think what I took away is when you have an data that is sensitive, and where it makes sense that it is decentralized stored,
mm-hmm.
and decentralized as well, validated and verified
and processed.
So then that is where the internet computer brings the biggest advantage for an enterprise solution.
I think yes, that's what I would say.
Yeah. That is what I take away, and I think that is as well a good finding at the end for this session. I thank you very much, Bjorn, for taking the time and giving us these insights as head of research at DFINITY in where the internet computer can be used for enterprise solutions. I think, yeah, as I said, you are still already 4 years on the market. The first solutions have been already launched. First showcases are there. Another interesting ones are in the pipeline and the coming. You have a lot of interesting talks with people that are looking how to protect sensitive data from American cloud providers, actually. and I think it will be quite interesting next couple of years with the internet computer, and I am really looking forward to see how it will succeed.
Thank you very much.
So thank you very much for the time. Okay. And thanks to everybody as well online for joining us here for another session of the Crypto Valley Social Club of the Enterprise Blockchain Vault. And I hope next year we will have again other interesting talks, and I'm very pleased to welcome you there as well and again. Thank you very much.